Hello, this is our second video of 4 of 1.2, the graph of functions. It's the first one we gave an overview, and here we're going to be a little bit more specific with a few examples, and we're going to be talking about determining if a graph is a function or not. And these are very simple. It's just determining if it is a function by a vertical line test. So I can go through these really fast. Function, 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 because each one of these will pass the vertical line test. So anything that wouldn't be a function would be like a circle or something like that. So these all are functions. So you can just come through here and you say, yes, it's a function. Yes, it's a function on this one. And yes, it's a function on this one. Okay. And then we're looking actually for the domain. Now, the domain is, remember, the x-coordinates. Is where the x-coordinates start to stop. And on this one, the arrows indicate it continues this way, and the arrows indicate it's going this way. So there is no boundary between these things, so it's all real numbers. So the domain is negative infinity to infinity. Now what about this one? Well, the domain on this one is where the x's start and stop. So this one has a point, there's no arrow there. It means it starts at 0 and it ends at 4. But it has an open dot at 4, which means it doesn't include 4. So it's all numbers between 0 and 4, but not including 4. So it looks like this, starting at 0 to 4, and 4 has a parenthesis on it because it doesn't include that number. And on this one, the domain, the arrows indicate that it goes on and forever in each direction. So therefore, it's also all real numbers. So again, we've discussed this before. Do you put the R or the interval? It depends on what they ask. If they don't ask, the R is fine. So you just have to follow their instructions. Now the range is the y-coordinates, is the outputs. So on this one is where the y is at. There are no outputs below the x-axis. It stays bounded above the x-axis. So although it continues down, 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 it never goes past the x-axis. So even though it doesn't ever get down to 0, it gets very close to 0. There's an output of 1, there's an output of 2, and all the numbers in between. Output of 2 to 3, and all the numbers in between. So the outputs are to infinity and goes down, 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 down until you get to 0. You don't include 0 because it never really gets there. So the range is 0 to infinity. On this one, the range, well, what's the lowest value? 0. What's the highest value? 1, 2, 3. So from 0 to 3, again, 0 is included. This is a dot, and the 3 is an open dot, so 3 is not included. So it's very similar to this one, but it's 0, 3 instead. And then the range on this one, as you can tell, the arrows indicate continues going on and on and on. So it's negative infinity, and it continues up and up and up and up and up. Oh, there's nothing up here. The graph plateaus up here. So the output is at, well, there's a 1 right there, and this is negative 1, 2, so it goes all the way up to 2. And so it's negative infinity up to 2. And what do you think? Do I put a bracket or do you put a parentheses? Yeah, it should be a bracket because 2 is included. All right. Now, intercepts. Intercepts is where it crosses the x-axis or y-axis. So x-intercepts on this one is where it crosses the x-axis. Well, number 12, it doesn't cross the x-axis. It gets close over here, but it never really gets there. So there is none. Y-intercepts, where does it cross the y-axis? Obviously at 1, 0, 1. And you write these as ordered pairs. 0, 1. Intercept is an ordered pair. It's not a number, it's an ordered pair. So you have to write 0, 1. Don't write just 1, or y equals 1. Y equals 1 is actually a horizontal line like we discussed back in the first chapter F, so that we did, review chapter. So you have to write it as 0, 1 as ordered pairs. Now, what about the intercepts here? Well, obviously the only point that crosses the x-axis and the y-axis is at the origin. So the x-intercept is at 0, 0, and so is the y-intercept. Okay. Now, what about the intercepts over here? Well, let's see, intercepts here. The x-intercept is where it crosses the x-axis, so there's two of them, at negative 3, 0, and over here at positive 3, 0. So there's two of them, so we write both of them down, and I'm just going to write it as plus or minus 3, comma, 0. And the y-intercept is where it crosses the y-axis, and obviously it's right there, and the y-intercept is at 0, comma, 2. And the last thing is on there is in instructions is symmetry. Okay, and that's something we don't discuss really heavily in this course. It's more of a visual idea than anything else. But they want to know if it's symmetric to the x-axis, y-axis, or the origin. Now, if it's symmetrical to the x-axis, that means if you fold it across the x-axis, they lay right on top of each other. So in this one, it doesn't do that. Let me give you one that has symmetry just to show you what I'm talking about. This one right over here has symmetry. If you fold this one across the y-axis, they just this part lays on top of this part, and this part lays on top of that one. That is symmetrical to the y-axis. Now, what about symmetry to the origin? Now, this one's kind of tricky. I look at it this way, though. Symmetry to the origin is if you get your piece of paper and you turn your book and you turn it upside down and turn it 180 degrees, and the picture looks exactly the same of the graph's image, then it's symmetrical to the origin. So let me give you one that's symmetric to the origin. That's not one of these problems. None of these are symmetric to the origin. This one would be symmetric to the origin right here. Because if you take that picture and you turn it 180 degrees, just rotate this thing around, and then have this part up here and have this part down here, the picture looks exactly the same. And that's symmetric to the origin. So there's rules for that. I'm not going to go into great detail with what that is, because that's not a major emphasis of this course. But that's what symmetric to the origin is. So this one right here is symmetric to nothing. You turn it upside down, it doesn't look exactly the same. It's not symmetrical to the x-axis, because if you flip this across here, there's no graph down there. If you flip this thing across the y-axis, this part right here actually should be over here then, and it's not. So, and this part right here should be over here, and it's not. So there is none. There's no symmetry here. Same thing here. Okay, you turn this picture upside down. It's not symmetric to the origin because it should be down like the x-axis, it should be down like that. Y-axis, it should be over here. And if you turn the picture upside down, it's actually in the third quadrant, not the first quadrant. So there is none here either. This one is symmetric to the y-axis, because if you fold this across the y-axis, it looks exactly the same. So there is symmetry, and it's to the y-axis. Okay? And this one right here, remember, looks like this, symmetric to the origin. So if you want to find one in the book that has symmetric to the origin, also besides this one up here that I gave you, if you look at problem number 14 in the book, that one's symmetric to the origin as well. So, but anyway, this concludes the second video of 1.2. We have 2 more to go. Our next will cover problems 23 through 28. And there are a few applications. So, thank you for watching.